It's harder to stop a large truck than a small car when both are moving at the same speed. The truck has more momentum than the car. By momentum, we mean inertia in motion. Momentum is the mass of an object multiplied by its velocity. A moving truck has more momentum than a car moving at the same speed because the truck has more mass. A fast car can have more momentum than a slow truck. A truck at rest has no momentum at all. A truck rolling down a hill has more momentum than a roller skate with the same speed, but if the truck is at rest and the roller skate moves, then the skate has more momentum. If the momentum of an object changes, it's because either the mass or the velocity or both change. The greater the force acting on an object, the greater its change in velocity and the greater its change in momentum. A force sustained for a long time produces more change in momentum than the same force applied for a short time. Both force and time are important in changing the object's momentum. When you push with the same force for twice the time, you impart twice the impulse and produce twice the change in momentum. The quantity force times time interval is called impulse. The greater the impulse exerted on something, the greater the change in momentum. To increase the momentum of an object, apply the greatest force possible for as long as possible. A golfer teeing off and a baseball player trying to hit a home run do both of these things when they swing as hard as possible and follow through with their swing. If you were in a car that was out of control and had to choose between hitting a haystack or a concrete wall, I think you'd choose the haystack. Physics helps you understand why hitting a soft object is entirely different from hitting a hard one. If the change in momentum occurs over a long time, the force of impact is small. If the change in momentum occurs over a short time, the force of impact is large. When hitting either the wall or the haystack and coming to a stop, the momentum is decreased by the same impulse. The same impulse doesn't mean the same amount of force or the same amount of time. It means the same product of force and time. To keep the force small, we extend the time. When you extend the time, you reduce the force. A padded dashboard in a car is safer than a rigid metal one. Airbags save lives. To catch a fast-moving ball, extend your hand forward and move it backward after making contact with the ball. When you jump down to the ground, bend your knees when your feet make contact with the ground. This extends the time during which your momentum decreases and decreases the force acting on your legs. The impulse provided by a boxer's jaw counteracts the momentum of a punch. In picture A, the boxer moves away from the punch. In picture B, the boxer moves toward the punch. Bad idea. A glass dish is more likely to survive if it's dropped on a carpet instead of a sidewalk. The carpet has more give. Since time's longer hitting the carpet than hitting the sidewalk, a smaller force results. The safety net used by circus acrobats is a good example of how to achieve the impulse needed for a safe landing. The safety net reduces the stopping force on a fallen acrobat by substantially increasing the time of contact. Suppose you catch a falling pot with your hands. You provide an impulse to reduce its momentum to zero. If you throw the pot upward again, you have to provide an additional impulse. If the flower pot falls from a shelf onto your head, you might be in trouble. If it bounces from your head, you may be in more serious trouble because impulses are greater when an object bounces. Increased impulse is supplied by your head if the pot bounces. The karate chopper imparts a large impulse to the bricks in a short time and produces considerable force. Her hand bounces back, producing as much as twice the impulse to the bricks. The block topples when the swinging dart bounces from it. Without the rubber head of the dart, it doesn't bounce when it hits the block, and no toppling occurs. The water wheels used in gold mining operations during the California gold rush weren't very effective. Lester A. Pelton designed a curve-shaped paddle that caused the incoming water to make a U-turn on impact. The water bounced, increasing the impulse exerted on the water wheel.